Hello students, so now let's see the standard results of integration. The main standard result of integration is integral x raised to n dx. We write it as x raised to n plus 1 upon n plus 1 plus c, where this n is not equal to minus 1. This is the standard result for integration, like we have for derivatives. How we write derivatives? D by dx of x raised to n is given by n x raised to n minus 1. So now let's take one example. Suppose you have x cube dx. So your n is 3. So x raised to n plus 1, that is 3 plus 1 upon 3 plus 1 plus c. So this is x raised to 4 upon 4 plus c. This is your integral. Now using this same formula, we'll find the integral of 1. How you can write 1? You can write 1 as x raised to 0, correct? So x raised to 0 using this formula will be what? X raised to 0 plus 1 upon 0 plus 1 plus c. So this is nothing but x plus c. So integral of 1 is x, using the standard formula. Now here are some integration formulas, indefinite integrals, standard results. Integral of 1 by x is log x plus c, because derivative of log x is what? 1 by x, right? A raised to x, integral of a raised to x is a raised to x upon log a. Then e raised to x is e raised to x. Like we have derivative of e raised to x, it is e raised to x. Integral of sin x is minus cos. Integral of cos is sin. Then integral of sec square x is tan x. Integral of cos x square x is minus cot x. Integral of sec of x into tan of x is sec of x. Integral of cosec of x into cot x is minus cot x. Now we have the inverse functions, which are integral of dx upon root of 1 minus x square, which is sin inverse of x, which is also equal to minus cos inverse of x. So we have it for tan inverse of x, then sec inverse of x. Like we have all the derivatives, for those derivatives you have integrals also. So if you know derivatives well, if you can remember derivatives well, you will remember the integrals also. Now let's see some examples of indefinite integrals. So here we have integral of e raised to 5 log x into x cube dx. So here you have to apply the properties of log. So you can write this as integral e raised to 5 log x can be written as e raised to log x raised to 5, right? Because we know that log of a raised to b is what? Log of a raised to b is b log a. This is the property or law of logarithm. So that we used here into x cube dx. So this will be what? Integral e raised to log. E raised to log is 1, that you know. So we'll get here x raised to 5 into x raised to cube dx. So now you have to use the laws of exponents. X raised to 5 into x raised to 3, that is a raised to m into a raised to n is a raised to m plus n, right? So we'll get here 8 dx. Then use the standard formula result for integration. So you'll get x raised to 9 upon 9 plus c. Okay, this is the final answer. Now let's see some properties of integration. Okay, how we can use this integration to solve some problems. Suppose you have integral k, some constant, into the function. Okay, then you can keep this constant outside and you can do the integration process. Okay, second thing is if you have two integrals, f1 of x plus f2 of x. Okay, so you can do this integration separately. Okay, suppose you have here plus or minus, so you can take one function at a time. Okay, dx plus or minus integral f2x dx. Remember that you have to write this dx every time you take function single. Okay, individual functions if you are taking, then you have to write this dx every time when you write them individually. Okay, and one more thing, I'll give you one example. Suppose you have function in a function. Okay, suppose you have integral of, you are given sine 2x. Okay, here sine is one function and you have one more function inside it, that is 2x. Okay, then you have to integrate this function first. Sine, what is the integration of sine? It is cos, correct? Minus cos 2x, and then you have to take derivative of this, that is 2x. Derivative of 2x is 2. Okay, that you have to write to divide. Okay, one more you do. Suppose you have integral e raised to 3x. Okay, here again e raised to x is one function and 3x is another function. So you have to write first integral of this function, that is e raised to 3x. Okay, and then you have to take derivative of 3x. Okay, and that you have to divide. So it is 3 plus c. Okay, keep these properties in mind. We'll solve some more examples. Okay, so this is the integral we have. So we can integrate these functions individually. Okay, now first write, now we don't know what is the integral of 1 upon x square. We know that integral of 1 upon x is log of x, right? So we have to take this x square above. So you can write 4 x raised to, if we take it in the numerator, it will become x raised to minus 2. Okay, minus 2 root of x. How you write root of x? X raised to half. Okay, plus cot square x. Now we don't know that integral of cot x, we don't know, we have not found it out, right? So we have to use our trigonometric knowledge. Okay, trigonometry knowledge, that is identities, which we have learned in 10th standard. Okay, to convert this cot x into something of which we know the integral. Okay, so close to this is cosec, right? So we know that 1 plus cot square x is cosec square x, correct? So we can write cot square x as cosec square x minus 1, and we know the integral of cosec square x. Okay, so we can write cot square x as cosec square x minus 1. Okay, dx. now you start integrating. So 4 we can keep outside. Okay, I'm integrating individually, but I'm trying to integrate it the whole function, okay, in one time only. So 4 x raised to minus 2 is x raised to minus 2 plus 1 upon minus 2 plus 1 minus 2 x raised to half plus 1 upon half plus 1 plus cos x square x, integral of cos x square x is minus cot x, okay, and integral of 1 is x. Then we have the constant of integration, which is c. So you write this properly. So this is going to become 4 into I will write here only, this will be minus 1, so this will be also minus 1. This is your 3 by 2, so this is also 3 by 2. Okay, so this you can write x is to minus 1 is in the numerator, so you can take it in the denominator. So this will become minus 4 upon x. Okay, this 3 by 2 you can take in the numerator, so 2 by 3 into 2, so it becomes 4 by 3. X is to 3 by 2 minus cot x minus x plus c. So this is the answer. Okay, once you get a lot of practice, okay, once you do lot of practice, you will be able to solve it faster, means in 2-3 steps only. Okay, for that you should remember the integration, standard integration results, should know them. Okay, and yeah, and how to convert this type of numbers. Okay, how to write them. Let's solve this. 1 minus sin x upon cos square x dx. Okay, so you can write this as integral 1 upon cos square x minus sin x upon cos square x dx. Okay, so integral 1 upon cos square x, you can write it as sec square x, minus this you can write it as sin x. You can split this cos square x into cos x into cos x. So sin x upon cos x becomes 10x, and one more cos x is there, so which is 1 upon cos x, so you can write it as sec of x. Okay, and you know the integral of both these numbers, both these trigonometric functions. So integral of sec square x is 10 of x minus integral of 10 of x into sec of x is sec of x, and the constant of integration, which is c. Okay, now here the integral, here you have some function inside root, okay, which is 1 plus cos 2x. Okay, now whenever you see this type of trigonometric functions, you have to use the trigonometric identities which you have learned in your 11th standard. Okay, so what is the value of 1 plus cos 2x? We know that it is 2 cos square x. Okay, similarly, if you get 1 minus cos 2x, that you can write it as 2 sin square x. Okay, so this 2 you remember, 1 plus cos 2x is 2 cos square x, and 1 minus cos 2x is 2 sin square x. Okay, same way you have the half angle formulas, means if you take this half divided by 2, then you will get here half angle, that is x by 2. Okay, sometimes they ask questions in this form also, so remember this. Okay, so let's solve further. This is easy now. So you have to take the root. Okay, so root 2 is a constant, you can take it outside. So integral of cos x dx. Okay, what is the integral of cos? It is sine plus c. Okay, let's see this. So this is integral 1 plus sine 2x. So we don't have any standard formula for this, okay, standard trigonometric identity for this. So we have to use our knowledge, previous year's knowledge. Okay, so this sine 2x, you can write it as 2 sine x into cos x, correct? And 1 you can write it as sine square x plus cos square x. Okay, so sine 2x you write it as 2 sine x into cos x dx. Okay, so if you notice this is a algebraic identity, which is that a square plus b square plus 2ab. So this is a plus b the whole square, right? So integral a and b are sine and cos the whole square dx. Okay, so taking the root and this square, you will get integral of sine x plus cos x dx. Okay, so write integral of sine, which is minus cos, and integral of cos, which is sine plus c. Okay, now same way, if you get here minus sine, okay, so we'll get minus sign here. So this will be a minus b the whole square. So this will be minus, this will be minus, and this will be minus. Okay, so you solved two problems in